Hello guys, welcome to this Unreal Engine tutorial about camera setup. We're gonna start with creating a pawn here. Alright, and this pawn we can name it BP player pawn. Alright, now this player pawn has nothing in the component and nothing in the event graph. If we drag this guy in, it doesn't have anything, just a little sphere there as a indicator that it's an actor that you put into the scene. We can go to the details panel and make sure that it's being possessed by player 0. So when we go play the game, we should be able to possess it. Let's place it in front of the table so we can see the little trophy here. Oops, a little too high. Alright. Now the question then becomes, how come we can see stuff even we don't have a camera in the player pawn? As you can see, there is no camera. And there are some mysteries. One thing is that there is no camera, but our engine could actually create a render location from here and just render from there. But the question then becomes, where do you get those camera setups, like the focal point, field of view, and things like that? There must be something that you can get from, or you use default settings. When you do have a player controller, let's actually do that. Then the player controller can actually give the Unreal Engine the information needed about the camera. You double click to open it, because it does have this player camera manager class, and it does have a little camera here too. This is actually not a camera. You cannot select it or anything. It's not a camera. Okay, but you can give it a camera manager class. All right. When it's none, then no camera, so Unreal Engine will use the default setting. Let's go ahead and create a camera manager right here. Alright. We're going to call this BP player camera manager. Okay, we can drag this to the player camera manager class so that it's being used by this player controller. Now, just to use everything we created here, we need a game mode. So right click, blueprint class, and game mode base. We're gonna call this guy BP game mode. Okay, now this game mode we'll use, if you double click to open it, you can drag the player controller as the player controller class, and then the player pawn as the player pawn class, default player pawn class. So we have our controller and pawn being used. Last thing we need to do is go to the world settings and drag our game mode into the game mode override and save it. Okay. So now if you go ahead and play, nothing is different because everything is default setting, of course. But we can go ahead and change some settings in the player camera manager here. Now this camera manager has the information needed for the render to use information like field of view. So we can change that to 200 just to see the difference. Let's compile and save. Now if you go ahead and play the game, you can see now our field of view is completely different. So the player controller do have a camera manager class attached to it, and this player camera manager class will manage the camera information of the render. One thing to be aware of is that this camera manager doesn't manage any camera. It manages the view target, and the view target can be anything. It can be actually a actor. Okay, it can be a lot of different things. I'm not sure if I can hack it, but let's try. So I'm going to create a blueprint class. I'm going to create a actor. I'm going to call it hack actor. Okay. And this is going to be my new view target. I'm going to change that. Okay. So what I'm going to do here is I'm going to double click to open it. Actually, I don't need to do anything here. Just drag it to the scene. All right. Now back to the player controller. I'm going to say when the game starts to play, we can get all actor of class. We're going to use that hack actor as the tab. So it's going to get all the hacked actors, and because we have only one here in the scene, so we should be able to get the first one. And then we're going to set the target, view target to this one. Okay. So we can say get camera manager, set view target with blend. Okay, and let's check that here. We can actually do a wait or delay to 4 seconds. So when after the game starts, after 4 seconds, we get this hack actor, and that's going to be our new target. Oh, we don't need the player camera manager. We can delete that. And so this one goes there. Okay. So basically means we're changing the view target to this actor so that we are gonna view from this actor. If that makes sense. I'm gonna change this actor just a little bit on the right side. Maybe we can see the little chair. We can right click and say palette this guy, so we can see exactly where this guy is being placed, and we can get out of it by clicking that little button. And now we got this guy out. Okay. So after 4 seconds, we will be snapped from this guy to this guy, but we're still possessing this pawn. So let's take a look. Now you can see we changed the view target to this new actor. Okay. And that's exactly what the camera manager stores, an actor to view from. That's all that is. There's no camera being managed. There's only camera information stored in the camera manager. Okay. Now if you you're curious on what's happening, you can view the source code. I have been researching on what's going on here. As you can see, the camera manager, this is the camera manager class, and you can see that the camera manager class has a view target. A view target is actually a structure and does have an actor as a target, and that's one of the core information the camera manager stores, which is the target you're viewing from. And then it does have point of view, point of view and all those different other settings. And this is actually the player camera manager class. You can see it's inherent from actor. And through this entire class, you can only see one camera actor here. This is the only camera actor pointer inside of this entire class, and as you can see, it's used for animation, right? It's not for viewport or anything. And other than that, there's no camera component or anything. See, no camera component involved in the entire construction of player camera manager, so it doesn't really store any information about any camera. It stores the information of where you view from by storing previously the target actor. which is here. It has a member variable called view target, and it stores that information here, and that's the primary one. Okay, it also knows where what's the owning controller of this camera manager is. All right, and there are many things happening inside. If you want to dig inside and see what's going on, you can. But throughout the entire process of possessing a Pong, I don't see anything involves camera. Okay. Anyway, so that's one of the things I think needs some sorting out so that we all understand what's going on. And I don't think I need this anymore, so I'm gonna go delete all these things. And I kind of want the camera manager to be more reasonable, so I'm gonna change the focal length field of view back to 90. Compile and save. All right. So when we're done with that, we're going to talk about if we do have a camera, then what happens. So we're going to give it a camera component. Okay. So if we do have a camera component, then we will view from this camera component. And as you saw earlier, that I actually changed the camera manager. Oh, sorry, I'm adding it to the camera manager. Let's delete that. So in the camera manager, we actually set the default field of view back to 90. And let's go to the player palm, and we're going to add a camera right here. Okay. And this camera also have those settings like the field of view is 90. Let's change that to 200 on the camera component we added to the player palm. Now the player camera manager has the default setting. Let's go ahead and play the game. You can see we're also we're using now the camera we added here as the viewing camera, and because that's the only one that does have 200 on its field of view. Okay, so that concludes that when there is a camera component, then Unreal Engine will use that as your eye. When there's none, Unreal Engine will use or try to look for the camera manager from the player controller, and if there is any, use the information from the camera manager to render. And the information include the camera settings, things like field of view, and also a view target that is from, again, the view target struct member variable of the camera manager, and that view target is a actor. Okay, it's not a camera. All right, with those two things, you got location of the actor, you got the camera settings, you can render. Okay, so that's how it works. Let me close that and back to the player palm. Now, one thing we can also ask is that what if there are two cameras, right? We have one camera here. I'm gonna give it something to look at and give it a little cube here, and we're gonna make the cube, drag the cube forward and make it smaller. Right. We're gonna move the camera away from the center. Compile and save. We can add another camera. Okay. Now this camera is gonna be also underneath the default scene root, so we attach it there. And we can call this guy camera 2, and this guy will be camera 1. And we can give this guy a sphere so that there is a different. Also make it smaller and drag camera 2 away. Alright, so we have two cameras. One is looking at a cube, another one is looking at a sphere. Alright, so close that and play the game. You can see now we're looking at the sphere. Let's drag the things out. Okay, oops. Let's also change the camera settings spec to 90, so we're looking at a normal field of view. Oh, that means that we're actually looking at the cube. That makes more sense actually. Let's go play the game. As you can see, we're looking at the sphere here. This is probably camera 1 then. It's camera 2. So we're looking at camera 2. And we're not looking at camera 1 in this case. So it will pick one, and that one is probably going to be the list. The first one that gets returned. And if you wanted to look at a different through a different camera, we can actually activate camera 1 and deactivate camera 2. We can do that by doing a delay for second, and we can actually do a set active. We're going to set active on the camera 2 and force it to happen and drag it there and set it to not active, and then we can do W to duplicate it, and we'll drag camera 1 to the target this time, and this time we're going to use active. So now we're deactivating camera 2 and activating camera 1. Now after 4 seconds, we should pop to camera 1, as you can see here. So that means in real time, our engines keep tracking which camera we want it to be activated and look through that. But of course, if you wanted to have a smooth transition, I would recommend to have only one camera and just animate it using a linear lerp or something like that. Anyway, compile and save. Okay, so that's a lot of explanation, but I think that's worth mentioning to clear things out, so we know exactly what's happening under the hood. All right. Now, some people may wondering like how VR works with this the Unreal Engine camera. It works right out of the box. The reason for that is because let's see, for the default control, if you go to player controller CPP or player controller, let's look for the control of the yaw. Oftentimes for the input from the player, we have this add yaw input. Okay, and that's where it is. If you look at the implementation, it does change this rotation input. And if you look at what's using this rotation input, you see that underneath update rotation, we do use the rotation input to create a delta, and we basically add the delta, and then player camera manager will take care of that to do the rotation and everything. And also going down, you can see it's actually checking if we have the XR system. XR means AR and VR, right? And it's gonna get that camera, and it also applying the head mount device rotation with its XR camera. So everything is taken care of using the same interface. Okay. And of course, that camera also is being controlled by the rotation of your device, of course, or where you're looking. Okay. So some basic setup I think people may need is, when you're doing teleportation, you kind of want it to be able to control after teleporting where the player is looking at. Okay. Let's actually set that up. I'm gonna go ahead and maybe we can start from scratch. Let's delete this player pawn, and I'm gonna delete the camera 2, sphere, and cube. Actually, let's keep that cube. I kind of wanted this cube to be some sort of like indicator, so we know where this camera is looking. Let's make a little shaft from it. So now we know where this camera is looking at. Okay. And we also drag the camera back. So change the moment to 0. Okay. All right. Now just to make things a little bit more clear, we can add another component, maybe a cube. Drag this cube as the scene root, and we're gonna drag camera maybe forward a little bit so it's not being blocked by the cube. And yeah, that's it. So in the player palm, there are two transforms. One is the camera transform, another one is the cube itself. So that when you're using controller to control it, those two can both be controlled by the rotation from the player controller. Okay, let's take a look at the different. I'm gonna go double click on the player controller. Okay, and let's set up some input. We can do that here real quick. We can look for mouse X. Oops, not get mouse X. Mouse X input, or we can just set up input right here. That's the right thing to do anyways. So let's go to project settings and go to input. I'm going to set up the axis mapping. I'm going to, oops, I have those already actually. As you can see, we have look right and look up. Look right is mouse X, look up is mouse Y. So we're going to use that to help us to do the control of the angle, because now if we go play, we cannot look around at all. So we're going to look for look right axis event, and we're going to add yaw input because we're on the controller. So add yaw input. This add yaw input is exactly the add yaw input here. Okay, we're calling this function, and let's create the pitch. So we're going to look up, and we're going to add pitch input. Okay, and that's the axis value. Compile and save. Now if we go ahead and play the game, we should be able to use the mouse to rotate, which we're not. Let's see. The reason for that is because in the player palm, none of those things, the camera or the cube, are following the player controller's rotation. The player controller wants to rotate. The palm itself or the camera, none of those two things want to rotate with it. If you want the palm itself to rotate, you need to select the palm and then use controller rotation, pitch and yaw. Let's compile and save. Go ahead and play the game. You can see now I can look around. Okay. I wonder why my palm is that high up. That's the hack actor. Maybe we don't have a player start. So let's actually just drag in a palm right here. Okay, and then let's make it auto-possessed by the player controller. We can just place it behind the table. Okay, now if we go play, you can see now we can look around. Let's hit F8 to cancel it, to unpossess. You can see what's happening is that its entire palm is rotating. The actual camera, if you look at the, we cannot really do that though. The actual camera here actually just follows along. The entire palm rotates. Okay, that's one of the setup you can do. And double click here, we can tell the palm to not rotate or to not pitch or yaw with the controller. If we set that up, play again, and we cannot rotate anymore. But now we can make the camera follow actually. So we can grab the camera, and then the camera also can follow the controller inputs. So open camera options, you can use palm control rotation. Okay, compile and save. Go play it. See, now we can also rotate. All right. So there are two ways. We actually go play it. Let's rotate a little bit and then hit F8 and go out. You can see now the difference is the palm itself doesn't rotate. The camera itself rotates. Again, that's because the palm itself will not use the control rotation from the controller, but the camera will use. So use palm control rotation means it will use the palm's controller's rotation. Okay, so should we use view control rotation of the palm? That's the view control rotation is the rotation the player controller wants to go. Okay. So again, the controller will have a desire to look at some, to rotate. The palm can choose to either follow it or not. The camera also can either follow it or not. Okay. So there are two ways you can do this. My suggestion would be, like, depending on what you want, you can of course use palm to control. Use controller to control both, or you can use controller to control only one of them. A particular example would be a third-person RPG. You have the character in front of you, then you probably wanted to check on use control rotation yaw, so that you can use the rotation of your view angle to control the direction of the character you're possessing. Okay, so it's totally arbitrary at which way you want to go. All right, so with that out of the way, we can go ahead and set up some of the teleportation I was talking about. Okay, so let's say I have a bunch of different places I want to teleport to. It would be wise to create a teleport target, so I can always just move there and look at the direction the target indicates. So I'm going to create a, let's just use this hack actor. I'm going to change its name to teleport target. Okay, so instead of this teleport target, I'm going to create two things, a cube and a sphere. They're all going to attach to the default scene root. The cube, I'm going to call it location, and the sphere, I'm going to call it look target. So what I want this teleport target to help me to do is I need two informations: where I want this pawn to be teleported to, and where I want it to look at. I want the pawn to look at. Okay, I can drag that away so that the pawn will be teleported here, and it's going to look at the sphere. Okay, and just some helper functions to help me find different things. Location is actually doesn't really matter that much. It's just a placeholder. So what I wanted to do is I want to get where the look target is, where this guy is. I can create a function. I'm gonna call this guy get look target. Location, and it's gonna return a vector, and let's call it look at location, and we're gonna compile and save. And then we're gonna drag this look target. We're gonna get word location, and this is gonna be our return value here. Compile and save. Back to the player pawn, we can actually create a variable just to keep things simple. This variable is going to be of the type teleport target, and this is going to be a object reference. I'm going to call it. We can of course create a list. We're not gonna cover that. It's outside of the scope of the camera thing. So teleport target, we'll make it public, so we can set it up. All right. So back to the pawn we placed here, we can drag in a teleport target and rotate it this way, and we can double click on the sphere to move the sphere to where the trophy is. So when I teleport, the pawn will be moved to where the box is. Let's actually move it up a little bit. Let's create a looking down angle. So the pawn will be teleported to here, and it's gonna look down to the sphere. Okay. All right. We can set up a quick input. I think I have that already. Let's go to the project settings, and underneath input, we have action mapping, and we have this teleport. And the key binding is T. Okay. So we can do that in the player pawn, or we can do that in the player controller. Either way, let's do that in the player controller because that's all our code is in now. So let's say if we hit the T button or the teleport action, oops, not this guy. When the button is pressed, we want to do the teleport. So one of the easy things we can do is we can get another pawn, get control pawn, and we're gonna cast it to our BP player pawn, so that way we can get the target here. So get teleport target, and we're gonna get actor location. Okay, and then we're gonna set actor location. The actor we're gonna set is of course our pawn, and drag it there. Our player controller will be attached to the pawn, so no matter where the pawn goes, and our controller will go there too. Okay. So we just go there, compile and save, and let's try this first. Go play the game, hit the T button. Now you can see we're at where the box is. Try it again. Let's take a look. Whoops, we're not there. We're actually at the origin. I think because we moved the box instead of the sphere. Whoops, let's delete that. Actually, let's delete that. It's a reposition one here because I was actually not moving the root, I was moving the location. So let's drag it over here and rotate, drag it in, and we're gonna drag this sphere again downward and drag it in and position it to where the trophy is. And this is gonna be our new teleport target right here. Okay, let's go play and hit T button. You can see now I'm where that little box is up here. Okay, just to make things easier, I kinda wanted to not seeing this box, so we can at begin play and drag this location here. Okay, and what we can do is we can set the visibility to not visible. So now when we go play and we hit T button, it's still here. Show new visibility is 0, location is here, this one. So we should be able to make it disappear. Let's try that again. I think this one is ourselves. Okay. So that guy is actually disappeared. We're still seeing ourselves as a cube. So, well, we don't really need the cube anymore. Anyways, so we're gonna actually make this guy also disappear. Alright. Those are just for debugging, so we actually don't need all these things. Now we don't have the cube anymore, hopefully. Still seeing it. Sleep mesh, go and compile and save, play it. Cube is this one. Cube 1 is, this is cube 1. Cube is disappeared, cube 1 is not, so I probably used the wrong thing. Anyway, so cube 1 is actually the one we use. Don't propagate to children. Let's go play it again. So now we don't see the cube, T button, we don't see cubes anymore. Alright, so we just had them. Now if we go play and hit the T button, we do teleport, but we're still looking at the direction we were looking at before teleportation. Right, so what we want to change is after teleporting, we also want the player to look at its where the look-at target is, where the sphere is, or where this guy is. We do have a function here, get target location, which will give us the location of this sphere here. So inside of the controller, after the teleportation, we're gonna set the rotation. Okay, so to get the rotation, or rather the delta rotation, we need to change to, we need to rotate. We need to know our current rotation. So let's get control rotation. This control rotation is the current rotation of our camera, okay? Because that's camera is the one that is following it, as we have set it up here. Use palm control rotation. Palm control rotation is this guy. This is the rotation of the camera, and we need to know the rotation. We need to go from the camera to the ball. Okay, so we need to know where the camera is. So we can do get camera manager view. You know what, I don't think that's a good idea, because the view target will be the palm, it's not where the camera is. There is an offset. So let's actually get the camera component back to the player palm. The camera components, we shall be able to get it right away, so let's try that. As BP player palm, let's get camera. Or we have only one camera. Yeah, this one. And we need to know where it is, so get word location. And this is where the camera is. And the other thing I need to know is get look at target location. Right? This is the location of the sphere. This guy. We implemented this function earlier. Okay. So we know where the camera is. We know where we need to look at. Then we need to use this function called find look at rotation. Start is where the camera is and is the target, of course, and this is going to be the rotation we need to look at the ball. So we have our current rotation. We know the rotation we need, so we need to calculate the delta. So we need that, and we're now this. We need to know the difference. So let's create a delta from A minus B, which means B need to add that much, this much, to get to A. As you can see, normalized A minus B. Okay, so we need this much change in order to change from the current control rotation to the local rotation we need. And this one, you can right click and split the structure pin to roll yaw pitch. And just like how we did the control here, we can use add yaw and pitch input to control that. So add yaw input here, and we're gonna drag the yaw to here, and then we're gonna create a add pitch input and do the same thing. So the pitch goes to here. All right, compile and save. So we calculate the delta and we plot that using add input. So let's go ahead and play it. Hit T button. Now we're looking at somewhere, but that's not where we actually need to look at. You see, it's changing all the time. It's keep changing, and it doesn't really give us the correct rotation, which is kind of a little disappointing. So let's take a look at why. We're getting everything here correctly. The locality rotation and the control rotation, which is the the two rotation we need. But when we do the add yaw input, you can see that the calculation will be either we're not. It's check if we're allowed to have local input. Of course we do. So it's gonna use this one. Oops, yeah, this one. The expression before the column. It's using the value we inputted in and multiply it by something else. It's called input yaw scale. Alright, that's one of the little tricky thing here inside of the Unreal Engine. It has implemented many features. Some of them maybe it may becomes an issue that if you don't know, then it's not gonna give you whatever the value you give it, but also have a multiplier on top of it. And that multiplier is actually here. If you look at the controller, you have this yaw scale and pitch scale. So we need to counter that. Right here, we're gonna go for a divide, and we're gonna divide the input yaw scale. That's the value at 2.5 we're seeing here, and that's gonna be the thing we divide, and then we apply the yaw input. We're gonna do the same thing here too. So for the divide and input pitch goes here, and that goes to the value. Okay, so now we're countering the multiplier from the C++ code that is actually driving it underneath. Compile and save. Let's go ahead and play. I hit T button. Now you can see we're actually looking at the ball right there. We can actually press F8 and jump out. You can see this line goes right across. Alright, we can also do experiment on changing the location of the sphere, maybe to the chair this time, and go play. I hit the T button. Now we're looking at the chair. Oops. So just be aware of that, and you have this kind of like limitation here. Not limitation, but it's one extra layer of calculation. Right, so just be aware of that. If you don't know it does exist, then it's going to be very mysterious why you're not getting the correct result. Of course, there are other ways, but this will work with VR, as what I have mentioned earlier in the beginning of this tutorial. If you just use the palm rotation here, if you don't use the camera rotation, and you use the palm to rotate, the VR wouldn't really care about it. So that's going to be a problem. So that's why you probably need to use the palm control rotation on the camera instead. Okay. Alright, so that's all I want to talk about the camera. I hope that those clears the confusion you have. So let's just revisit the concept I have mentioned. So first of all, you don't need a camera to be able to look through. When you don't have a camera, the rendering engine will try to ask the player controller about the information of the camera. It will ask where the camera is or where to render from and the camera settings. And those two things will be inside of the camera manager. Now, if you don't have a camera manager, then it's going to use the default setting, right? Which is the possessed palm will be the view target, and the camera information will be the default setting of camera information. If you do have a player camera manager, then the player camera manager will tell the rendering engine where to render from and what is the render setting, the camera setting of the camera. They'll set it up here. When you possess a palm, when the controller possesses a palm, in the code, it's really deep, so I don't want to go there. But in the code, it will set the view target when you possess the palm. And yeah, it's going to set the target to the new target. It's not here, it's somewhere else. So that the palm you possessed, that actor will become the view target, which is where the camera is when doing a render. Okay, and the camera information again is on the settings of the player camera manager. So two things, location and render setup, those two things are taken care of by the player camera manager. If you do, however, have a camera, then it's going to render from the camera you specified and the setting of that camera. Okay, that's it. And of course, the camera manager have other settings, that the modifiers that could be applied on the camera. Okay, we'll talk about that maybe another time. All right. And to control the camera's rotation from the player controller, you have to grab the camera, which is this guy, and you have to make it use the palm control rotation, which will use the control rotation the player controller wants to look at. The player sitting in front of the camera wants the monitor wanted to look at that rotation as the rotation of the camera. And I think that's a better setup. Or you can also say use the control rotation to also specify the yaw sometimes, or pitch, or whatever. So two places you can set up to make them follow the control rotation from the player controller. Okay. Now, one last thing I think is important is that multiplayer, when you use add yaw input, make sure that you subdivide the input yaw scale so that they do get you the correct result. And that's it. That's everything I want to talk about the camera system inside of Unreal Engine. And I think this is gonna help a lot of beginners a lot. And this is also my own note for my future reference too. All right. Thanks for watching. See you next time.